Hi there, everybody. So we today are going to finish our exponent laws by beginning with our quotient of powers law. Yes, the quotient of powers law. Before you learned about the negative exponents and you learned about product of powers law. This time we're going to do quotient of powers law. And just like is in the name, quotient of powers law is all about division, dividing exponents. Bang, bam, boom. Now, the one thing I always want us to remember anytime that we have any of our exponent laws is that all of these laws only hold true if the base is the same. Okay, if the base is the same. So before I actually tell you what the quotient of powers law, yep, I'm going to have you try to figure it out on your own. So we're going to look at some patterns and see if you can figure out what the quotient of powers law is. So first, I'm going to start with 11 to the third power divided by 11 to the second power. Super simple. So let's keep it simple. I'm going to put this in fraction form just because fraction is the same thing as a division sign and it makes it a little bit easier to see. So in order to solve this, I have to right now, from what I know, put it in expanded form. So 11 to the third power is 11 times 11 times 11 times 11, and that's divided by, or over in this case, 11 squared, which is 11 times 11. Now when I evaluate this, I see that I have some common factors. So with common factors, I can divide them out and they will equal 1, which will leave us with less factors. Not cancel, but divide. So 11 divided by 11 is going to give us 1. So those become 1. 11 divided by 11 is going to give us another 1. That becomes 1. So now we're left with 11 over 1. So our final answer is going to be 11. And if we do not have an exponent, then we can assume the exponent is what, JP? That's right, 1. So we know now our first clue is 11 to the third power divided by 11 to the second power equals 11 to the first power. All right, clue number 1. Now we're going to try it with some other numbers. So I will do, this time I'm going to do 13. And I'm going to do a larger power. So I'll do 13 to the 6th power divided by 13 to the negative 2nd power. Let's make things interesting. Okay, again, the best way for me to do this that I know of now is to put it in expanded form in a fraction and then see how I can divide out the common factors. So 13 to the 6th power is the same thing as saying 13 times 13 times 13 times 13. That's 4, 5, and 6. Okay. I'm going to take all of this and I'm going to divide it by, now 13 to the negative 2nd power. How do we write the negative 2nd power if we're going to not have it with a negative sign? How do we do that? How do we do that, Mila? You're exactly right. We write it as the reciprocal of 13 to the 2nd power. So that would be 1 over 13 to the 2nd power. Since 13 to the 2nd power is 13 to the 2nd power over 1, and when we do the reciprocal, we just flip the numerator and denominator, and we get the reciprocal. So now we have 13 times 13 times 13 times 13 times 13 times 13, divided by 1 over 13 squared. Now, I know that if this is 13 times 13 times 13 times 13, it's over 1. So if I'm going to divide this by that, I am going to try to use my keep change flip. So I want to put this also in expanded form so that everything's in the same form, 13 times 13. I have 13 times 13 times 13 times 13 times 13 times 13 times 13 over 1 divided by 1 over 13 times 13. Now, I know if I do division, I'm going to keep this. I'm going to change my sign, and I'm going to flip the second fraction. So let's do that. I keep this, and change my sign to multiplication. And then when I flip, I find the reciprocal of 1 over 13 times 13. I get 13 times 13 over 1. Now, based on our product of Power's law, we know that when we multiply together, we are just adding the exponents. So let's see if that works in expanded form. 13 times 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 13. On the top, we have 1, 2, 3, 4, 5, 6, 7, 8 factors of 13. So that's 13 to the 8th power. Or we had 13 to the 6th here, and then 13 to the 2nd here. So when we add those exponents, we would still get 13 to the 8th. So it does hold true. And then 1 times 1 gives us 1, and we know that anything over 1 is just itself, so our final answer is 13 to the 8th power. So our second clue is that 13 to the 6th power divided by 13 to the negative 2nd power equals 13 to the 8th power. Okay. Now you might start to see a pattern, but let's see if we can do one more, maybe a little less difficult, and see if that pattern that you're thinking about works. So I have 5 to the 3rd power divided by 5. Let's do 5 to the 4th power. Makes things interesting. 5 to the 2nd power. Again, I'm going to put that in expanded form in fractions so that it's easy to see how the factors can factor out. 5 times 5 times 5 times 5 over 5 times 5. Now I know that 5 divided by 5 is 1, 5 divided by 5 is 1, and I'm left with 1 on the bottom and 5 times 5 on the top, which, if we simplify that, is 5 squared. So now I have 5 to the 4th divided by 5 squared, which gives me 5 squared. Now let's check this out. Do you see any patterns here? Do you see anything in the exponents? Flynn, what do you think you see? Okay, I hear you. I think you're right. So let's see if that works. What I heard Flynn say is that keep the same base, and then you subtract the second exponent from the first exponent. So let's look if that works right here. We have a base of 11. We have 3 is our first exponent, and we subtract the second exponent, and we end up with x equals 3 minus 2, which is x equals, 11 to the 3 minus 2, which gives us 11 to the 1st power. That is true. Ding. Let's see if this works with this really strange one, because this one took a long time to figure out, and I don't want to have to do that every time. So keep the same base, like Flynn said. Now we take the exponents. The first one is 6. Now we're going to subtract, so I put a negative sign, but this is a negative number. Now, I know that I can't just drop the negative number, so I keep the negative number and put it in parentheses. Now, when I simplify this, I keep my same base. 6 minus a minus 2, bang, bang, and change. I get 6 plus 2, which gives us 13 to the 8th power. Beautiful. And last one, just to give us peace of mind here, we have 5 to the 4th minus 2 equals 5 to the 4 minus 2 gives us 5 squared, which is our answer who? Bang, bang, bang. So let's review what it is that pattern is that we're seeing. With the quotient of Power's law, you have the same base. You keep the base. You keep the base, and you subtract the second exponent. Order is really key here. From the first. So I like to also put an example of that using using variables as our exponent. Oh, yep, you're right. You are so right, Constanza. I need to put that T. There we go. All right. So in an example here, I would put x to the y power divided by x to the z power. Let's make these numbers so it's easier to see. I don't know, I'm trying to complicate my life. X to the 7th power divided by x to the 3rd power equals x to the 7 minus 3 power, which is x to the 4th power. Okay, I'm going to leave this. We can stop the video for a second just so that you guys can take down notes and make sure you know what the quotient of powers law is. If you have the same base, you keep that base, you subtract the second exponent from the first, and you're left with your simplified form of your exponent. Okay. Now that you've copied down your notes, what I want you to do is in groups practice this law. So I'm going to give you a couple, 3, and some of them are a little more difficult than others, and you will stop the video, and then after you stop the video, you will do these together in groups, and then we'll go over them after you're done. So the first one, I have 7 to the 9th power divided by 7 to the negative 3rd power equals, who knows, you know? Now I have x to the 2nd power divided by x to the negative 2nd power equals, who knows. Now I'm going to do something a little bit different. Well, 9 to the 3rd power times y to the 2nd power divided by, I'm going to put these in parentheses, divided by 9 times y equals something. Okay. I'm going to give you guys 5 minutes to figure those out in groups, and then we're going to go back over them. So go ahead and stop the video, and then we'll come back. Okay, now that you've done them in groups, we're going to do them together here just to make sure that we have everything right. So 7 to the 9th and divided. What do we do? What do we do? Carl, yes, we do. We keep that same base. I'm getting fancy with my 7s. Take the first exponent, 9, subtract the second one, so I put my negative sign. Oh, yes, that is so right, Petra. We do have another negative sign, so we keep that second one in parentheses. Simplify, we get 7 to the 9 plus 3, which equals 7 to the 12th power. Pat yourself on the back there. All right, next, we keep the base. Double, what do we do to the exponents? You're right, we subtract the second one from the first one. So let's put the first one there. Subtract the second one. Oh, you're right, Bella, we do see a negative. So we're going to put that in parentheses so that we don't forget it. Then we get x to the 2 plus 2, which gives us x to the 4th power. Now, this one's a little bit different. So I want to put this into other terms so that we can check ourselves and make sure that we can see everything that's going on. So instead of keeping this like this, I'm going to put it into fraction form, which remember the fraction bar is the same thing as a division sign. So I have 9 to the 3rd divided by times y squared over 9y equals. Okay. Now I see that I have 2 of the same base here. So I'm going to take those bases. I'm going to take that base, put it on the outside here. I'm going to take the exponents, 3 here. There isn't an exponent here. What is the exponent when there's no exponent? Emiliano? 1? You are such a genius. -1. Now we see another common base here of y. So put the y here, 2, and again, there's no exponent there, so we're going to make it into 1 because that's what it is, even though we can't see it. So now we're going to simplify this. We get 9 to the 3 minus 1, which is 9 squared, divided by, or times y to the 2 minus 1, which is y. So it's 9 squared y, or 81y. Now, let's see if this worked in expanded form too. 9 times 9 times 9 times y, times y, over 9 times y. If we do that, we get 9 divided by 9, which is 1, y divided by y, which is 1. We end up with 9 squared y, which is 81y. All right, now you guys are going to learn about the power of Powers' law next, but in between that, I'm going to switch videos. So stop, take a little break, and then we will come back in just a second.